Hello, this is Mrs. Decker, and in this video I will go over Objective 1D, the evidence of nebular theory. So with 1D, we want to be able to explain why space objects other than the Earth are better evidence for nebular theory than looking at the Earth itself. So first we want to start by talking about Earth rocks a little bit. So we need to remember how old the Earth is. The Earth is the same age as our sun and the entire solar system, which is 4.6 billion years old. And then the next question we want to think about is, are the rocks of Earth 4.6 billion years old? If you remember from last week, we looked at a couple of different rock samples from around the Earth, and we found that no, the rocks of Earth were not 4.6 billion years old. And we want to think about why not. The rocks of Earth are not as old as Earth because Earth has changed drastically since it was first formed due to a couple different things. First is tectonic plate movement, which we will talk about more in Objective 2. The second is volcanic activity. And the third is weathering and erosion. Remember, the Earth has an atmosphere much different from any other space object. And because of the atmosphere we have lots of weather on Earth, which causes lots of weathering and erosion, which changes the rocks pretty drastically from the time they were first formed. So then the next question we want to think about is, if no humans were around 4.6 billion years ago to see the Earth being formed and to know that it's that old, how do we know how old the Earth is? We do have several pieces of evidence to support nebular theory for the formation of our solar system and our Earth. And as a part of your project, you will have to be able to explain several of them. So I will go through a few of them now. So the first piece of evidence is the orbit and the rotation of the planets. So the way that all of the different planets orbit pretty similarly around the sun is a big piece of evidence for nebular theory, because remember, as the nebula began to collapse, it began to rotate, and through that rotation the planets were formed, and they continued to rotate around the sun. All of the planets also rotate along their axis, which wouldn't happen unless the solar system was formed the way that it was through nebular theory. The next piece of evidence that supports nebular theory is the composition of the planets. You should remember from a couple of the activities we did on nebular theory, the inner 4 planets are all composed of rocky metals. The outer 4 planets are much larger and composed of gases. And the way the nebula arranged the elements as it rotated supports the composition of the inner versus the outer planets. Our next piece of evidence is the moon, both its age and its composition. So to understand why the moon is a good piece of evidence for nebular theory, you need to understand how the moon was formed. So most of the inner planets do not have moons. Only the Earth has a relatively large moon. However, the outer planets all have several moons. So scientists needed to figure out how Earth got a moon when the other inner planets do not have them. So the most widely accepted theory is the giant impact hypothesis that says at the time when the planets were forming, a large planetesimal about the size of Mars hit the Earth, and because of that impact, a chunk of Earth broke off and became the moon. So the moon is made up of the same types of elements that the crust of Earth is, which we would expect to be that way if the moon is actually a piece of the early Earth. Right? The age of the moon is also important because when we age the moon rocks that have been brought back, they show us that the moon is about 4.6 billion years old. So since the moon does not have an atmosphere the way that Earth has an atmosphere, weathering and erosion has not happened on the moon, so the rocks are the age that they should be since they have not been changed since their formation. So the moon shows us that the Earth is 4.6 billion years old. Our next piece of evidence is the age and composition of asteroids and comets. So asteroids are pieces of rock that did not combine to form a planet as planets were being formed. And so when we find asteroids that we can actually take the age of, we find that they are the same age as the age of the solar system, which is 4.6 billion years old. They are also made from the same materials that most of the inner planets are made of, which support that they were made at the same time from the same materials as the whole solar system was being formed. The next piece of evidence to support nebular theory is cratering on other planets and asteroids. So I'm going to click ahead here to show you some pictures. So these are some pictures of Mercury, Venus, Mars, a picture of the moon, and a picture of an asteroid and a comet. And if you look at all of them, you should see one big similarity between all of them. They all have these craters that are all over on them. When we look at the Earth, we do not see these same craters. So the craters are here on all of the planets and asteroids and things because during the early formation of the solar system was a very violent place. There were lots of asteroids and bits of rock and planetesimals flying around and constantly crashing into everything else that was forming. So that's why we get all of these craters. The Earth looks different though, however, because remember the Earth has a very protective atmosphere, which allows for weathering and erosion. So in the Earth's early formation, it looked similar to those other planets and asteroids. It had all of those craters. But as the atmosphere developed and weathering and erosion and plate tectonics all happened over billions of years, the evidence of those craters has been largely erased from the Earth. So the fact that all of the planets and asteroids and the moon have these craters support the theory of nebular theory for how the solar system was formed. And the last thing we're going to talk about for evidence of nebular theory is observations of other solar systems forming. So we can actually look into other areas of our galaxy and see other solar systems forming and forming in the manner we would expect them to if nebular theory were true. So when I say that we're looking into other parts of our galaxy, we cannot take actual pictures the way we think of pictures. These would be mostly infrared pictures like this one. So this is a part of our galaxy, and as you can see, these are infrared pictures. The red is much hotter and warmer than the green or the blue. So the red is where the star would be forming in the center, and you can see it sort of looks like a disk as we would expect with solar nebular theory. So that is how we know that solar nebular theory is how our solar system was formed. If you have any questions, please let me know.